So for the first one, b is a negative exponent, c is to the 0, and d is a positive 6 exponent. So you should have ended up with d to the 6 over b to the 4th. For 17, you have 2 to the negative 3, and then you have a negative 1 in front of it. So you should have had negative 1 over 8. Negative 1 over 8. And then 21, you have negative p squared times q to the negative 2. You should have ended up with, and they wanted you to actually plug in here, 2 for p and 3, negative 3 for all of these. For this particular one, they wanted you to plug in those. You should have ended up with a 4 ninths. 4 ninths. For 17, the only thing taken to the power here is the 2. So it's kind of like this. Negative 1 times 2 to the negative 3 is kind of how you want to think of these if that's not in parentheses. And so 2 to the negative 3 is 1 over 2 cubed. 2 cubed is 8, so you have negative 1 times 1 over 8, which is where you get your negative 1 over 8. For 21, they want you to plug in values. So if you were to actually do these, negative p if you square it is p squared. And then q to the negative 2 puts q on the bottom squared. And then they told you in your book that p is 2 and q is negative 3. So you have what, 2 squared, negative 3 in parentheses here. So you're going to square the negative. And that's when you end up with 4 over 9. All right, so for scientific notation, you can go one way or the other. You can write it in scientific notation. You can write it in standard notation. It does remind you up here that your numbers need to be between 1 and 10, inclusive of the 1, exclusive of the 10, meaning it cannot be 10, but less than 10. N is an integer, so it's going to be some decimal form. Some number, negative or positive for your value of x when your 10 is taken to a power. They give us this example. The space probe Voyager 2 traveled 2,793,000 miles. Write that number in scientific notation. So go ahead and try 31. In sections 3 and 4, we introduce properties of exponents. So they list out these, and I put them all together. 3, 4, and 5 is where we introduce these properties. If you multiply like bases, you add their exponents. When you take a power to a power, that is when you multiply the exponents. If you have a group inside that is taken to a power, everything in the group, whether it is multiplication or down here like division, everything is taken to the power. And when you divide like bases, you subtract their exponents. So these are the properties that we are using to do these particular problems. We also did scientific notation. Remember, for scientific notation, you divide the numbers themselves, and then you use this property right here for the division of the tens. Those are like bases, just subtract those exponents. Your final answer for these should be in scientific notation. So if it's not, you then have to adjust your decimal based on whatever you have. So go ahead and try those 5. All right, so for this one, the groups are actually not being taken to any powers, so we can just simplify those. I am going to look, if these were taken to a power, I would deal with that first, but since they're not, I'm just going to combine my like bases here. I have 5 and negative 4. Those are both coefficients, and neither one is being taken to another power. So I can simply just multiply the 5 times the negative 4. If I look at my c's, I have c to the negative 4th and c to the positive 8th. So I can multiply those. C to the negative 4. And since I'm multiplying like bases, I'm going to end up adding those. And then for the last one, the m doesn't have anything to combine with. So I just have m squared. And then I'm just going to simplify each of those pieces. So I have 5 times negative 4 is negative 20. I have c to the negative 4th times c to the 8th. I'm just adding those. So I'm going to say negative 4 plus 8, which gives me c to the positive 4. And then m doesn't combine with anything, so I just have m squared. For a geometric sequence, we talked about common ratios. And then this just finding the formula for your particular geometric sequence that you've been given. If you want to find your common ratio, you're going to take your second term and you will divide it by your first term. And that will give you your common ratio. So for this one, I would take 75 and I would divide it by 750. And when you do that, you're going to get 1/10, which would be your common ratio here. If I wanted then to set up the equation for this one, because you are going to need to know how to do that, I would say, well, this particular equation would look like this. My initial condition here, my common ratio to the n minus 1. And so that would be the formula for finding any term in that particular sequence. All right. We also had it where we were given functions that were set up in that y equals ab to the x. And they want us to find specific numbers within that given the domain. So if they give you a domain like this, just like from your bell work when we did this, you are just going to plug it in. So if I plug in a 1, I'm going to say it's 2 to the first power. If they want me to plug in the 4, then I'm going to say 3 times 2 to the 4th power. So if they give you a function and they give you the domain and want the range, you just plug it in, which is just like what we did for our bell work. And then the last thing we did was exponential growth and decay, all right? And so for exponential growth and decay, remember that when your rate is greater than 1, so if we had 8%, right, then we have growth. If it is a fraction, it's going to be decay. So if I looked at this first one, my initial condition for this would be 32. And my factor here would be 0.75. So this particular one would be decay. I would say, well, this thing is going to get smaller. That one is going to be decay. For this next one, if I wanted my initial condition, my initial starting value would be 5.2. My B for this one is 3. So this particular one is going to be growth. Growth. And so initial condition is always the first number that they give you. And your growth factor or decay factor is the one that is being taken to a power. All right? Questions on those?